So here's a problem we've all had, I'm sure. So you're testing something out. You just need a quick hit of some voltage to power something, but your big ass expensive bench power supply is in use for some other project right now, and you don't want to take it apart. So what do? Well, of course, you take out your fully restored Heathkit IP-18 little power supply here, which can give you 0 to 15 volts, up to half an amp, and it's perfect for just when you need that little quick hit of voltage to power something on, ad hoc. And it's got a voltage adjust here, and it's got a current adjust. You can turn it on. It has a little light, floating outputs, so they're not referenced to the chassis, so you can cascade this with other power supplies. Very nice little power supply, and this one, of course, is fully restored, and I use almost daily. But the main problem you have here is, yeah, it's 0 to 15 volts, and it's current limiting up to half an amp. But how do I know what voltage I'm getting out? Well, the answer is you add some meters to it. And that's what I did. Of course, you want a voltmeter and a milliamp meter. And as luck would have it, on Amazon, and I'll put up the listings, you can buy exactly the right meter you need. In this case, it's a 0 to 15 volt little panel meter, and it's a 0 to 500 milliamps. So it matches exactly the specs on this power supply. So if it's on, so I can turn it on, and if I turn the knob all the way up, I get just slightly over 15 volts. So yeah, the power supply can go just a couple volts after past 15. And that's nice. Now there's no load on it. That's why the milliamp meter isn't showing anything. But we'll fix that. So I'll show you that the milliamp meter works. And as you might imagine, I simply plumbed in the voltmeter across the output, and the milliamp meter is in series with the positive output, and that's all it is. And I've measured this with obviously a proper multimeter, and these little meters are surprisingly spot on accurate. So apart from the mechanical zero adjustment here, so that when it's off, it really reads 0. It takes a second to discharge. For example, on the milliamp meter, you see this is exactly on 0. That's all. That's basically the only calibration you need, and it is quite accurate. So I'll turn it back on, and if you need 5 volts, there's your 5 volts, pretty much spot on. To show you how the milliamp meter works, let's do that now. Listing for the little voltmeter, and they sell it in other ranges, but it conveniently have a 15 volt version here. And here's the 500 milliamp meter listing on Amazon. Again, also with just the perfect range for this application. So this is the point where you're probably asking, why did he use analog voltmeters and ammeters instead of, digital panel meters like these silly things that you find all over the place? The answer is twofold, of course. First of all, analog meters are much more period correct because, after all, this is late 1960s, very early 1970s test equipment. So a digital panel meter like this would have been totally incongruous. More importantly than this, though, you got to power these somehow. These take some kind of voltage just to operate, and then you feed in separately the voltage you're actually measuring and the current you're measuring. So I'd have to build in some sort of micro power supply inside the IP-18 in order just to run the panel meter. Because obviously if you dial the IP-18 all the way down to 0, there's nothing to run the meter, so it can't show anything until you dial up enough voltage that actually can turn the panel meter on, and that's just no good. So that's why we're using analog voltmeter and analog milliamp meters instead of stuff like this. So let's put a load on this thing. So here's a 33 ohm, probably half watt resistor, something like that. It's a Chinesium resistor from the parts bin. It is 33 ohms. I checked it, but for the sake of arithmetic, let's just make believe it's a 30 ohm resistor. because that turns out to be quite convenient to make the milliammeter work. And so if I'll just put this down to free up my hand. It's across the output. So if I turn the current limiting all the way up, since it's if it's a 30 ohm resistor, if I do full scale 15 volts, I'll draw exactly 500 milliamps, and so I do. But I'm not going to leave it there for very long. Why? Because if I'm pushing 15 volts and this thing's drawing 500 milliamps or half an amp, 15 times 0.5 is 7.5 watts of power being dissipated somewhere, and it's being dissipated on this poor little half-watt resistor. I don't happen to have a 7 or 8 or 10 watt power resistor for this, so yeah, it does get, if I left it on, it does get hot and it would fail. But I just wanted to show you that yeah, the milliammeter works as you would expect for whatever load you put on it, up to the rating of the power supply. So again, a little modification of this power supply, just adding on metering, which makes it ever the more useful.